We have found ourselves connected to these strange travelers throughout time. In the past, their appearance led us to link their arrival with milestone events that shaped history either for disaster or for good. Some believe their collision with Earth caused the extinction of the dinosaurs, while others think they brought the seeds of life for our future. They carry inside them clues to the beginnings of our solar system. But what are these recurring visitors in our sky? Unraveling the mysteries hidden beneath the surface of comets will not only shed light on our solar system's past, but may also provide valuable insights about its future. On the great stage of the heavens, few objects have inspired more curiosity, fear, and fascination than comets. Often seen, little understood, these cosmic nomads carry revealing clues about the origins of the solar system 4.5 billion years ago. Comets have played, and they continue to play, an active role in the history of our solar system, shaping and transforming the environment around them. It may have been comets that seeded Earth with water, nitrogen, oxygen, and carbon-based molecules, the building blocks of life. Traditionally, comets were puzzles we tried to solve from afar. But what if we could get close? Not just to look, but also to reach beneath the surface of a comet's nucleus, to reveal matter from the time when the solar system was forming. In July 2005, NASA will do just that, when the two-part Deep Impact spacecraft stages a collision with a comet named Tempel 1. The comet will overtake the impactor spacecraft, causing a collision that forms a large crater. Long-hidden clues will be brought to the surface while an observing spacecraft watches nearby. This active experiment, deep in space, will begin a new era in the study and exploration of comets. What a comet looks like is determined by how close it is to the Sun. Away from the Sun, it is a dark, irregularly elongated nucleus described by the astronomer Fred Whipple as a dirty snowball. The nucleus spins slowly on its axis. It is made of ice, gas, and dust, the bricks and mortar of the early solar system. The surface of the nucleus is probably a tarry black mixture of debris held together by the weak gravitational pull of the comet. As it nears the Sun, however, solar heating causes the comet's nucleus to generate a coma and a tail. The coma, a brightly glowing halo surrounding the nucleus, and the tail are made up of gas and dust driven off the nucleus by the heat of the Sun. The nature, structure, and behavior of the nucleus are the greatest unsolved mysteries in the field of comet study. 6 months before impact, the two-part spacecraft launches from Cape Canaveral in Florida, atop a Delta II rocket. One spacecraft is a flyby observer module, which carries the second spacecraft, a copper-nosed impactor weighing over 350 kilograms or 770 pounds. Instruments on board both the impactor and the observing flyby spacecraft are safely housed inside the launch vehicle for the ride into space.
Green board. 5, 4, 3, 2, 1. Main engine start and liftoff.
Soon after launch, tests and calibrations are run on all systems, and the flyby spacecraft and impactor are directed to the path of Tempel 1. Along with a dedicated science and engineering team, the task of observing Tempel 1 is shared by a global network of professional and amateur astronomers who have trained their telescopes on the comet since 1999. Long before the spacecraft launched toward Tempel 1, a partnership formed among the project team, astronomers, and Deep Space Network engineers to ensure a successful plan for targeting the comet. When the Deep Impact spacecraft nears the comet, both high and medium resolution cameras on board take infrared spectra and visible images of Tempel 1. These data and images are relayed to the Deep Space Network antennas on Earth. After years of using models and Earth-based observations of Tempel 1, the navigators on the Deep Impact team now use these closer images to precisely target the comet. Observations are also taken from big and smaller telescopes on Earth, as well as some Earth-orbiting observatories. The Deep Space Network antennas relay final commands to the spacecraft. 24 hours before the impact, the flyby spacecraft points directly at the comet and releases the self-guided impactor. In preparation for the collision, the impactor aims itself at the onrushing comet. Final images and observations are taken from the impactor's cameras and sensors. Meanwhile, the flyby spacecraft alters its course one final time, maneuvering to a path that will miss Tempel 1 by 300 miles. From there, its instruments can best observe the closest approach of the nucleus and avoid ejecta debris. Final timing is critical to align support from Earth and other space-based observing instruments. Everyone waits for the final moment. The comet collides with the impactor, which is vaporized in a shower of debris sent up from the newly formed crater. Depending on the makeup of the nucleus, the resulting crater could be as large as a football stadium and as much as 14 stories deep. The way the crater forms should give us a good indication of the internal structure of the nucleus. Meanwhile, the comet nears the flyby spacecraft, which tilts up through a cloud of dust and debris to collect visible images and infrared spectra. These fingerprints of the ejecta and crater are sent immediately to the DSN antennas on Earth. As the comet approaches at the tremendous speed of 23,000 miles per hour, and sweeps by overhead, the flyby spacecraft rotates over to record its departure. As they consider this new data from Deep Impact, scientists re-examine questions posed at the beginning of the mission. What lies beneath the surface of a comet nucleus, and what does it tell us about the early building blocks of the solar system? Can a comet's repeated journeys around the Sun exhaust its supply of gases and cause its death? And how will this extended knowledge of comets bring us to a new understanding of both the past and the future of our solar system? Knowledge gained from Deep Impact will be combined with that of other missions. Past questions will be answered, new ones will be raised. Throughout history, people looked to the skies to explain the unknown. Results from Deep Impact will answer questions about our solar system's future and bring forth hidden pieces of its past through these strange and beautiful visitors, comets.
T-minus 35 seconds. Hydraulics go. T-minus 30 seconds.
T-minus 30 seconds. Everything is go at this time for the launch of Deep Impact. T-minus 20. T-minus 15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of a Delta II rocket carrying Deep Impact, NASA's journey to unlock the mystery of the solar system's origin.
Coming up on T plus 36 seconds, we are now supersonic. Vehicle now passing an altitude of 3 miles, downrange distance 13 miles, and coming up on 2,000 miles an hour. First stage performance still looking good, and we have exceeded max Q. All ground start motors have tapered off, and we have reached burnout. And the air starts have ignited, and all 6 ground start motors have jettisoned. See the normal level of disturbance after solid motor jettison, and that has damped out nicely. We're now passing T plus 86 seconds into the mission. Air start solid motors all burning symmetrically, and they've passed their peak chamber pressure, coming up on T plus 105 seconds. Stage system still looking good. Now passing an altitude of 19 miles, downrange distance 45, and a velocity of over 4,000 miles an hour. Main engine and verniers continue to burn well, good chamber pressures there, and we are tapering off, reaching burnout of the air start motors. Jettison. All 3 air start motors have jettisoned. And we have pressurized the LOX tank. We have reset the relief reset. We can confirm a slow increase in LOX tank pressure, now passing T plus 150 seconds. First stage performance still looks good. Main engine and verniers still burning well. Nice good chamber pressure there.
Everything continues to look good with the Deep Impact payload on board. The 9 solid rocket strap-on boosters have been jettisoned, and the Deep Impact spacecraft is on its way to catch up to Temple 1 in July.